So we're here to show you our split ranged valve setup here. So we have an RTD, our temperature sensor transmitter. Here's our program that we've written in basic ladder to convert our 4 to 20 electrical analog signal coming in from our RTD into a 4 to 20 output coming to these valves that we've split ranged here. Here's our output setup. We have a series of lights, just different temperature ranges. We have a indicator that our cooling system's on, heating system's on, and then a loss of input warning light. And here's our little LCD readout. And you can see that our current room temperature is 24 degrees. So if we come over to our valves here, we have a heating valve here with our sliding stem, a current to pressure transducer, 4 to 20 milliamp signal in, 3 to 15 psi out to our positioner here, which gives the valve feedback, telling it where it's sitting and where it should be to get it seated in the correct location. Same thing with our cooling valve here, different style of positioner, different style of valve. We have our sliding stem reverse acting at this point with how we set up our positioner. So both valves are running on one 4 to 20 milliamp signal with our sliding stem opening from 7.2 milliamps down to 4 milliamps, and our cooling valve here opening from 8.8 to 16.8 should be its full stroke. So we'll plug our RTD into our little rod oven here. As you can see, our temperature starts climbing. As we cross that 30-degree threshold, cooling light comes on, appropriately ranged lights come on, and we actually start to see some rotation in our butterfly valve there. So as that 4 to 20 milliamp signal comes up, now we're just crossing 15 here, and we should saturate our signal of our output right here as we cross that 16.8 mark. There we go. So that's our 80-degree threshold for fully open on our cooling valve. As we come up to 100 degrees, which is what our little oven's preset to, we still get a change in readout, but our cooling valve is fully saturated at this point. Then as we come down to the other end of our signal, a little ice bath here. So you can see we come back down across that 80-degree threshold. You can really start to get a bit of that drop out of the valve as we come down and cross that 8.8 milliamp 30-degree threshold, which is the ideal temperature for our process. Our rotary valve fully closes. As we cross 20 degrees on the low end, our sliding stem valve starts to open, approaching 0 degrees. We're sitting at 10 degrees now, 5.5 milliamps. Our sliding stem valve continues to open. You can see our heating light on, and our sub 20 light is on. And as we come down and approach 0, we should get saturation of that sliding stem heating valve. Now sitting about 1 degree, 4.2 milliamps. As we come back up from 0, you'll see that sliding stem valve start to close up into the 20-degree range there. Now again, we've crossed that 30-degree threshold, so that rotary cooling valve starts to open again. Now, one last piece to this. We have a fault condition where a loss of input causes an error signal to output. So if we lose this 4 to 20 signal coming in from our RTD, both valves fail safe into a closed mode, and we get that readout on the screen and a flashing warning light. Good.